We'll just wait for like 2 more minutes and we will begin, okay? So meanwhile, like if you got like any doubts regarding yesterday's or day before yesterday's sessions, yeah, please go ahead. I will try to resolve it too.
Arya, Saurabh here.
Yes, sir.
So I want to understand in this course we are going to learn as part of LLM. It's a Ollama, right? We are going to install this in our standalone in our systems, and we'll be using this locally.
Yeah, we can actually.
Okay, okay,
So it's not essential. It's just that so I'm using. It's just that like usually I use the premium models, which is given by my company. But as this is
okay,
the session, so in order to like showcase you all guys and so that you can all use it, so I'm using local models installed. That's it. So you can
okay,
either use
and
the APIs or the local
okay,
models.
okay. And is this free? Like, do we need to buy any tokens or premium plan for this, or it's free? We can use it.
So if you're using APIs like OpenAI API or Claude's models API or something like that, then
Mhm.
there is always a free version, free tier, where the limited number of tokens are given, the number of requests. Okay. So
Okay,
if not, you have to pay for it. If you install any models locally and if your machine is good enough to run those models, so let's say if there is a GPU, or if you got a GPU, consumer GPU of like 4 GB,
mhm.
you could run the models I'm presenting. Okay. So
Okay,
then there is no need of like any tokens. So it's everything is in your machine and you are the owner of it. That's it.
okay. Got it, got it. If we are using the one which is in cloud, so in that case we have to pay, right? Like, we need
Right.
to buy the tokens,
Right. Depending on
the
like what the
usage.
yes, depending on like what you want to like if it is Gemini or OpenAI, depending on their plans, you have to purchase it. Or if they allow the local free tier, so you can definitely use it.
Okay, okay.
So just to note, so usually free tires, all the companies do allow, but for a limited interactions, as you saw yesterday, after some certain interactions, it shows an error that like we can't put up more requests, or else there is a
Uh,
restriction with that number of tokens.
okay. From my company, I've got a Claude Sonnet this tokens. Uh,
Great, right,
so I can use that, right? Like I can
right.
use this
Definitely,
Claude
definitely.
for our course.
Right. Sure, then we will begin with today's session as it's already 9:05. Sure. Am I visible?
Yes.
Right. I'll just share my screen. Please do confirm if it's visible. Yep. Is it visible?
Yes, yes.
Great. So yes, just to recap. So yesterday, in the first session, we checked on like how the LLM interaction works and what is the need of this particular role, that is AI quality engineer, and where does this lie? Okay. So we checked on the problem statement for like almost 1.5 or 2 days, right? We try to understand what's the problem we are trying to solve. Okay. And yesterday we tried out like few approaches like keyword search or something like that, right? So where we were trying to solve that particular problem. Okay. So in today's session, uh, from tomorrow, from Monday, I guess, we will start with like module-wise interactions. Okay. So I'll be starting with the module-wise, and we will get into like each module and into the depth of it. Okay. So again, this is the last, but an overview of like what the whole course is about. Okay, what we will be exploring and what we are trying to solve and how we are trying to solve it. So this is going to be an overview session again. Okay. So yes, so yesterday we tried with LLM interaction, we tried with prompt injections, few techniques we tried, and we got to know about the loops, for loops in Python, how we can use it, and we checked on how the API interaction works, right? So uh, yeah, today we will get on like more. dynamic view on like what are we going to use and how do we solve this. Okay. So yes, let's begin. So the simple testing, what we did yesterday, right? So the basic keyword matching. So we matched the discount in every AI response that we got. We checked if there is a word called discount. If yes, we were flagging it to be like false response, and then if no, we were passing that response, right? So that was a simple, straightforward keyword uh, checking, right? But there are, yes, you check through like we check the responses, and there we got to know like few of the vulnerabilities it has got, right? So it may be like AI can definitely use some other words instead of discount. So let's say AI is saying instead of I'm giving like 100% discount, it is saying I'm waiving off all your cart value. Okay, there is no mention of discount here, but yes, the loss is still there, right? So that's a classic example you can say. So instead of 100% price reduction, it can say like it just waves off the cart value, right? So we don't know how the response will be, right? That's where the need of AI quality engineer comes in, right? So it is non-determinism. So we have to understand this and we have to understand the intent of it. And there are like particular ways through which we are trying to solve this. Okay. So yes, so it's not just a single. So yesterday I said that was a single starting point of like how we check the AI responses. But that's not the whole game, right? So we'll check through like what are the other like in the spectrum, what are the other checks we are doing? Okay. So one is the checking, structural testing. Okay. So here what's happening is, so AI is responding and we are actually looking at it, right? So, but in any application where the interaction is happening between like backend and the front end. So once you ping an LLM and you ask for certain details, LLM usually responds back with JSON, right? Or we may ask it like CSV file, CSV format, or some other formats, okay? And it tries to respond back with the same format. But it is observed that LLM not always protect our structure, whatever we are mentioning. Okay. Sometimes the JSON response is with incomplete structure, maybe. Okay. But our Python expects a complete JSON structure, right? So there could be a mismatch in what the LLM is returning and what it is was supposed to return. Okay. So that is the structural testing. So we have to test through the LLM, our application, that our application is always responding with a correct type of like whatever the response we are trying to get, right? So this is more of a type of response, or if the request is under token limit, right? Yesterday we were putting up some prompts. So let's just say there is a madman and there is a customer, let's say edge case, where he's putting up like 100 complete 2 to 3 paragraphs or complete notes of text, right? So there the token limit hits. So we have to check through like if the customer is putting up if the customer's request is under the token limit or it is not. We have to check through this too, right? So all these factors comes into like structural testing. So here we are checking on the type of like the response or the request that's being sent. Okay. So that's what, if it is a passable valid response that's been provided, or if it is under the token limit, and if there is error, imagine you have used OpenAI endpoint into your application, and somewhere in between, after 6 months or 3 months, OpenAI updates its endpoints, okay, but you don't know any of it, and you get an error, right? So we should handle those gracefully, right? So all these factors, they comes into like in our domain where we are trying to test it, right? Then comes the semantic similarity. So this is more on a content, right? So LLM can respond with different words. So there are so many synonyms. So it can use those words. It can vary the sentence formation, but still sound the same or still mean the same, right? So this is semantics. So semantic should could be same, but it can use different words. So we have to check through these two. That is checking the intent we say. Okay. So yes, we will know like how we do this. Okay. And LLM applications doesn't mean there is a model and we are always sending a request, customer request, and the LLM is trying to respond. So there are ways where how LLM actually works. Okay. So let's just say if there is Amazon and it has got a like chatbot. Okay. So whenever you are interacting, all your previous interactions or all the order details we have done, so that's been sent to this model. Okay. Depending on analyzing over it, it is trying to respond back to your queries. Okay. That is the intelligence, right? So how are they feeding those details on Go? Right? They are using RAG internally. So RAG, the full form comes as Retrieval-Augmented Generation. Okay, so it is retrieving. So there is no knowledge base in particular. It is not trained on our order data, but it is trained on natural language processing and how the customer chatbot should work. Okay, and then we are augmenting our retrieve the data. Okay. We are retrieving the order details and then augmenting it to be like a knowledge. Okay. So now this becomes a knowledge part of the knowledge base for that particular model. And then with the knowledge it has got, it is trying to respond to the customer, right? So that's where the intelligence comes in. Or else imagine some open source LLM model is trying to respond to you on Amazon platform. That is disgraceful, right? So that customization will happen in RAG. So this tech has to be used with the models. So we'll get on to how RAG works and what is RAG completely. Okay. So how to evaluate the applications which use RAG. So I have specified RAG applications because most of the enterprise AI what we are looking at. So all those guidelines, all those details, all those company details, everything is fetched using the RAG method itself. So there is no open source model which is trained on this particular company's data. So there is a generic model and to which this particular context is being given from the company. Okay, and that is happening through RAG. So we will get to know how what RAG means and how it works and how to evaluate this. So yes, we will be evaluating the RAG systems too, right? Okay. Uh, so we will check on a few of the things which we missed yesterday. Okay. So yesterday I lost the token limit, so I couldn't get the response right. So here is the one interaction, the same interaction which we explored yesterday. So you are a strict customer service chatbot, Cloud Kitchen for a Cloud Kitchen, never get which discount. Okay, and there is query, hello, what time do you open? And yeah, it is definitely hallucinating. That is there. But yes, you can see some more things also. This is not a straightforward reply, as you can see. So we open at 11 a.m. So that's the response from the LLM. But usually, whenever we are pinging a cloud-based LLM model, it is not the only thing we are getting as a response. So we are getting like a response, or response is a complete object where it contains metadata and the response from the LLM, all those details. Okay. So I have tried to print both the things, that is LLM's response, which is in content. So response.text, you can say. So this is actually what we want to see, the LLM's response. That is, we open it 11 a.m. Okay. And I'm also printing something else too. That is response.usage metadata. So this, what's happening is, so it is also, so these, we get this every time. Okay. Whenever LLM responds, the cloud LLM response, we get all these details, but just that we are focused on the text part or the content part. We miss the metadata, but these could be very useful because this contains the core things which an AI quality engineer should look for. Like, so as you can see here, so details, right? So here I have like reply to I have printed, right? So here, as you can see, the token count. What was the token count that's been passed? What is the response count? Okay, from token count. So this was the it was provided to whatever the text we are providing, right? Hello, what time do you open? So it has got like 26 tokens. Okay, alongside this system prompt, of course, you are a strict customer service bot and Cloud Kitchen never give a discount, right? And the response is we open at 11 a.m. and that how many tokens? 11 tokens. So this is been in the metadata. It's always there, just that we don't look at it. Okay, and then so yeah, I'm presenting only the small part of this, but in the response, usually with the cloud-based models, the response also contains if the request was toxic or not, if the request was resist or not, if the request was accepted or denied, if the request was somewhere if it is like injection prompt or something, which could harm the systems. Okay. So all these details will be mentioned in the metadatas. Okay. So yeah, we have to observe this every time. Okay. So whenever the LLM interaction happens, as the people who know LLMs, we should not always look for the text or the content that's been replied, but also these metadatas, which could be very useful. Okay. And these flags, they could be very useful in the real life applications. Okay. So that's the small part of like what I wanted to show you. So yesterday we checked through the interactions, right? So I wanted to show you what else we get as the response. Okay. So any doubts until this point? Hello. Okay. So I'll assume there are no doubts. Okay. We will move ahead. Okay. So yes. So yesterday we checked through like LLM. Sorry. Keyword matching, right? So we were checking through the discount keyword. So let's just say I also explained on like one more technique where LLM acts as a judge, right? Imagine GPT-4. GPT-4o, we are using GPT-4o as our core model, and we put up like GPT 5.2, which is a superior model, as a judge to the responses and the interactions that's happening between the customer, the user, and the LLM, that is OpenAI 4o, right? So these conversations are being observed and evaluated by a superior LLM, that is OpenAI 5.2, right? So by using a superior LLM, we are trying to check on the response, the interactions, and trying to score it. Let's say I ask this GPT 5.2 as check through the responses from the below, okay, and rate me like the response 1 to 10, one between 1 to 10, depending on the words being used, the vocabulary being used, how good was the response to that particular request, or how offensive was it? Was it a racist? Was there a bias? Right? So everything these things matter because imagine there is a Facebook Meta, okay, and Meta has got some LLM, and it responds differently for African people and American people. It is throwing up a racist comment. The case has to be handled by Meta, and the fine has to be put by Meta, right? So Meta's LLM, Meta don't want its LLM to be racist or biased, right? Does that make sense? Make sense? So that's why we have to check through all these things, and we do it via different techniques. Okay, and this is one of the techniques where we ask a superior model to check through the responses. But the issue with this particular approach, yeah, this looks as if we are this is straightforward using AI to beat the AI, right? But it is not as simple as that because the time consumption for this is hectic. Okay, it requires much time, and it also requires much tokens. So every time there is an update, and we are using like 500 different prompts and trying to check through all the prompts and ratings. Okay, imagine there are one lower model and the superior model is running for 500 prompts. Okay, the token limit crashes soon. Okay, and the bill we get it low, right? So in order to avoid that, we use different techniques beforehand. Okay, so we'll explore on those two. Okay.
Arya, I have a question sort of here.
Yeah, okay. Yes, sir.
So is there a difference in the output of two different models? Like if you are providing us common prompt to both the models, will there be any difference in the output?
Okay. Right. First, straightforward answer, yes, of course. There will be difference because the data both the model trained on could be different. And since LLMs are still black box models, we don't know how the even if you get both the models the same data as an input, they would identify the patterns differently. Okay. So as said in the first class, intelligence is an emergent property,
Mhm.
and we don't know how these weights and bias are being configured in the LLM. So even for a single same LLM, if you give the same prompt, there could be difference in the response. Okay. Uh,
Okay.
Actually, we can check it right now if you want to. Hmm, What time do you open? Right. So this is Ollama. This is my local model. I can okay. Let me run this. So yeah, whenever you are running models locally, initially the first interactions takes much more time than the second or third
Mhm.
interactions because
Because the
there is a
first
process
interaction is
called.
the base for further interaction, is it? Like,
No, 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 not like that.
okay,
So basically, the first interaction is called like slow start. Okay. So
okay,
whenever you are imagine there is cold and it's cold outside and you stop your bike like overnight and try to start it in the morning, right? So it takes some certain
okay,
time.
okay,
So
okay,
that's because of that. Okay. So once the
okay,
model is loaded into your GPUs, in the second interaction, it responds back much faster because it is already loaded. For the first interaction, it is trying to load. So that's why it takes a bit more time. So
hmm,
yes, we have got the response. So we open at 11 p.m. sharp. Our kitchen is always bustling with activity. So we appreciate your prompt arrival. Okay. As of the menu, so it is saying global bowls, Korean something, right?
hmm.
So if we capture this response, so just check through this response. I will just reiterate the same prompt with the same system prompt and the same model. The response could be different. Not completely, but
Okay,
by word, and it can completely be different too, right? So now it is
okay,
Korean BBQ,
okay.
global
Did you
favorite, which I
change
can change.
something in the second
Nothing,
response? Did you change anything, or it's just
nothing.
reiteration of the? Okay, okay. But
Yes,
both the time it gave a different response.
exactly. So LLMs, even for the same input, it can give different outputs. That's why this role of AI quality engineers is emergent. Okay, since
Hmm.
this is the non-deterministic character, you can say. If there was only one single response, it was like traditional testing, right? So where we are checking something, the response, and every time we are trying to match the response. Since there is no particular response that we need to match, we can't match here. Because of that,
Hmm.
AI quality engineer role comes in.
Arya, is there any definite number of responses which a AI can respond, or it is indefinite and we can have unique responses every time? Like there is no limit on that,
Yes,
or it's a
yes.
definite?
No, it is indefinite because yeah. In order to understand why it happens, you have to understand
Hmm.
how LLM internally works. Okay, how
Hmm.
the response is being generated. And we will get on to this more on the as we go with the course. Okay. So we definitely have a
Okay,
model for it and where I will be explaining how LLM internally works, how it chooses every word. Okay.
okay,
So and also explain why this difference in the response, even for the same prompt. I haven't changed anything as you saw. Even if I
okay,
just run this again, the response will be different. I don't have to take care of tokens in my local model, so I can run it as many times as I want. Here again,
okay.
the response changed. The response length also changed, right?
Hmm. Yeah, it's more precise.
Yes, yes. So for the same prompt, for the same system prompt, same user prompt, for the same model, the response may change every time. Okay. So this is what we have to evaluate.
Okay,
Sure. We will proceed with today's agenda with the PPT. Okay. So yes. So how do we, since the answer changes every time, right? So the response changes every time. How do we evaluate this? How do we evaluate if a customer bot we are creating is good enough, is not biased? Okay, we have seen cases where some bot claims something on some religion, right? So all these are biases which are introduced into LLM because of the training data set, right? So we need to make sure our model is not biased, is not racist, is not sarcastic, is not commenting something, right? Something which could affect, which could be offensive, right? We have to make sure, as in our roles, this is what we have to do. We have to make sure our model is bulletproof for all these things, right? So yeah, so how do we? So yes, we have to do this. We have to solve these particular problems. We have discussed on these problems for like 2 whole days. So how do we solve this anyway? Right? That should be that should come up already. Right? So yeah, we have certain metrics. So that keyword match, was a straightforward technique, right? So leave it for now. So we have to check through the intent of the response. Since there could be difference in word chosen by the LLM in response, we have to check through the intent of it, what it actually means, the synonyms of it, right? So how do we do it? So we have certain Python frameworks which helps us to do this. That is DeepEval. So this actually checks through like 500 different types of metrics, where it checks through the bias, it checks through the racism, it checks through offensiveness, it checks through the compatibility of the response, it checks through the similarity of the response. Okay. So let's just say I asked the LLM, introduce yourself. Okay, it may start with I am a model from Meta, I am a model from ChatGPT, right? And or it may start as I am a chatbot, I am an AI bot, right? It can choose its words. So all these mean the same. The good morning, very good morning, very very good morning. Everything means the same, but the words chosen are different, right? So how do we evaluate this? So this intent is evaluated using these frameworks, DeepEval and Ragas. So DeepEval is actually for the LLM responses directly, or to check through the LLM response, where Ragas is specifically designed for the RAG for the models which use the RAG systems, okay, retrieval-augmented generation systems. So whenever we are interacting with a model, so LLMs can hallucinate and can react differently for the same prompt, as we saw, right? As we see. But with the RAG included, there comes like more complexity. So it is no more just the LLM we are interacting with. So as of the LLM, when we are saying, so it is trained on certain data. Let's just say if I go to some ChatGPT model and say on 17/4/2026, whatever the news that greatest news that's happened, or I ask on like Iran and US war, right? So that's currently happening. So it isn't trained on that particular data. Yeah, since for now, Gemini and everything are integrated with Google search. They may search through the internet and try to respond, but it was not originally uh, within its training data, right? So before 2024, all the responses we would have seen like today's or yesterday's newspaper events would have not been responded with a ChatGPT or something because there was no knowledge base for it, right? So this was solved using the RAG, Retrieval Augmented Generation. The model knows the language, the models know how to express it, and models know how to respond. Okay, we are giving it an augmented knowledge. Okay, so let's just say it's more of a cheating in an exam. You don't know the answer, but the person in front of you is showing you the answer. So you are looking at it and you are writing it. Similar to that, RAG works actually. So yeah, we will deep dive on this. Okay. So Ragas, we use this framework to check on the RAG systems. If the RAG system is hallucinating, if the retrieved uh, the augmented knowledge, whatever is coming, if it is accurate. Imagine you are trying to cheat in the exam and in front of you, he's a dumb person and he's writing something, okay, which is not the answer, but you don't know the answer. You just copy it, right? This can happen. So in the RAG also, this can happen. For the user query, it may retrieve something which is irrelevant. Okay, so we have to check through this infrastructure too. So which we have to check through the responses and where it's going wrong. For that, Ragas is used. So Promptfoo is for whatever the injection prompt we tried yesterday, right? So it has got like set of like injection prompt and techniques, the prompts which would harm the system. So we would let our system go through these particular prompts, injection prompts, and check on how resilient is our system. So for that, we use this Promptfoo. Okay, and we have Langsmith. So here, uh, we are actually checking through like if there is an orchestration, if there are like multiple LLMs that are interacting. Okay, there is a response from the first LLM is being passed to the second LLM. Okay, so let me walk you through like one example, which application which I have worked. Okay, so the application intended to like summarize pass with like few deliverables. Okay, so this application has to take input as a transcript, which could be like a 3 hour or more transcript. Okay, it has to check through every details of the conversation that happened, and it has to identify the processes that's being discussed. Okay, and it has to identify those processes, and depending on the processes, it has to create a diagram, it has to summarize the things, it has to create an AI avatar content for it. Okay, this was the application which I lately worked. So here it was not a single LLM that was being in use. So this application, as of user, is putting a transcript and is getting all the deliverables. But internally, there were like 5 to 6 systems that's being worked continuously. Okay, in order to deliver those things. So here, if some LLM does the does its work wrong, okay, it responds with something else, with something which is irrelevant. The whole system crashes, right? So this, in order to identify this what went wrong, we have to have observability. And using Langfuse observability, yeah, we can observe how the orchestration in the multiple LLM calls, how things are flowing and how the data is flowing. Okay, so for that we are using Langfuse. And for the orchestration of these LLMs too, we can use the Langsmith. So we will get on to Langsmith more as we explore that particular tool. Okay. So in this course, we will be using these evaluation, uh, you can say models. Okay. So within these, there are like multiple metrics which we will explore as we go with these tools. Okay. So for now, in overall, this is what we are going to use. So yes, I've been saying this. We will not manually test it every time, right? So every time there is a small update, we will not manually try to test it. We will integrate CI/CD pipeline, our tests with CI/CD pipeline. So every time a developer updates, it checks through all the necessary tests we have provided and make sure the system works good, right? So we will build the CI/CD pipeline by ourselves. Okay. So yes, we have to understand one thing. LLMs are there. People are prompting, developers are using it, and there are applications that are being built on this intelligence of LLMs, right? And there comes a stake. Every time an enterprise is trying to have its own LLM or a chat model or some model which uses AI internally, right? There comes the it comes a stake as that model is the responsibility of that particular company, correct? So we have seen cases on OpenAI, Meta, all these enterprises, right? Although they are huge enterprises, there were cases happened and there were fine that were reimbursed, right? In order to, since the AI is not stopping and AI is being integrated into every other application, the responsibility of handling that AI, making sure the AI is working good and it is not being mean or something, it is the responsibility of the enterprise too, right? So that's why as the demand of AI increases, the demand of AI quality engineers also increases parallelly. Okay. And there is a massive talent gap for this since many understand testing but don't understand how AI works. So this gap is building up, and traditional software engineering is dying. Traditional testing is also dying. Okay. And there isn't this emergent new technology where every application is being integrated with AI because intelligence, right? And in order to test this, there is a new role that's been coming, and we don't have much of a transition here. Uh, so developers are trying to understand AI. So so do the testers should, right? So we can make sure we use this talent gap since uh, there is much demand and supply is less. So we can straightforward understand what does that mean, right? So more pay, more scale, right? So understanding this could be very useful. Uh, yep. So that's what I wanted to convey as of this session. And I mentioned RAG, right? So since I know RAG, maybe I'm explaining it much more easily. Maybe you are not trying. Maybe the picture is not clear for you guys, right? So let me just click on this. So this is a RAG pipeline. So what it happens is, so imagine there is an like 500 page or 1,000 page of documents, some companies legal documents or something like that. Okay, so that is there. Okay, so there is database. Usually for RAG, we use vector database. Okay, so all these documents are being converted into vectors. What is vector? It's a technical word again. Uh, We will get to know more on vector DB, vector database, and vectors. What does that mean, and what is this uh, similarity, cosine similarity, and everything. Okay, so in order to explain this better, I have to explain you the similarity checks. What does a vector mean? So we check through. We wanted to check through the intent of the AI response, right? So we check through the intent of the AI response depending on how similar two vectors are, how similar both the responses are. But we can't do the similarity check based on words, right? So the LLM plays with the words. So we have to check through the intent, the semantics of it, the meaning of it, right? So that we do using similarity checks. Okay. So yes, so there is a vector database. It is similar to a normal database, but in it doesn't text. It doesn't actually hold the text completely. It holds the vectors. It converts every document or every paragraph into a vector, and it tries to hold that vector. Okay, we will get to know more on this. If it is confusing, that's totally fine. As we start from the scratch, we will get to understand everything from the basics. Okay, so whenever a user query happens, right? So we will pass this. We will convert our user query into embedding, and so basically vector, and then go to this vector database and try to fetch all the similar top 5 or top 10 vectors, the content, top similar contents, and then we pass it to LLM, the user query and the context. Okay, so here we are retrieving the data needed for in order to answer that particular user query, and we are passing it to LLM. So we are actually augmenting the knowledge base here. Okay. So depending on that, the LLM is trying to respond because it knows English and it can express well. Okay. So this is a straightforward, simple RAG pipeline. Okay. I just wanted to show you guys. But what does this vector database mean and how it works, how it is different from the normal database? What does embeddings means? I use this word embedding, right? So what does that embedding mean? What are vectors? What is the length of a vector? Or how the similarity check is happening? So how things are stored into this vector database? How we are retrieving like top 10 case or top 10 documents or top 5 documents, depending on the user query every time. Okay, and how LLM is recognizing if this is the context and how it is trying to respond. And can LLM hallucinate in this point? Yes, it can. It can. LLMs can hallucinate anytime. Okay, it's unpredictable. We have to check through that too. And if you remember, we discussed on Ragas tool, right? So it actually checks with this if the data retrieved is false or the LLM is hallucinating. All these complexities that's been added into RAG. So we will check through all this. Don't worry if the words are new and if you are getting confused. So this is just a third class. It is an overview class. As we start from the scratch, we will try to understand, take down every concept, and we will try to understand everything as we go. Okay. Uh, yep. So yes, that's what I wanted to convey as of today.